JD didn't write, right? All right. Proportional. Let's add a little bit to that. The sides are proportional. Are the angles proportional? What do we know about the angles within these figures? So part of it is congruent. The angles are exactly the same, but the sides are proportional. We just talked about a little bit earlier that these are the three ways to prove triangles similar. Similarity means that figures are proportional. How are proportions solved? We do a little cross multiplication. That's all that is asking for. If I write something down, make sure that you write it down. This problem, what did you get for an answer? D? D is the correct answer. That's one way of looking at it. If I have a triangle within a triangle, I recommend that you redraw the triangles, show the letters on the vertices, Q, J, K, Q, R, S. One way to look at this type of situation with similar triangles is to look at corresponding sides. So when I separate the two triangles and look at the two figures, I'm actually looking for corresponding sides. And that's what this was. We had QR with QJ, they correspond, and we had QS with QK. That's one way to develop your proportion. There's also a shortcut that we talked about way back in chapter 6. Sometimes all you need to do is look at the pieces. I believe I called it the pieces shortcut back when we did it. Sometimes you can just look at those pieces and you'll end up with the same effect of this proportion. So if I saw QJ corresponding to JR and QK corresponding to KS, that's a perfectly legitimate proportion also. So you could see the pieces proportion, or you could see the corresponding sides proportion. You got to be able to jump between the two. If you have these pieces, and that's enough information to help you solve for a missing piece, you can go ahead and use this. If you don't have that, or if you're looking for one of the two parallel sides, you have to do a corresponding sides. These two aren't involved in this shortcut. This happened to be a corresponding sides situation. This is already shown to be similar. That means I can do a proportion. 6 corresponds to 9. I have to have something that's complete with 2 corresponding sides. 3 corresponds to my missing side. 6x equals 27. X equals 27 over 6. Looks like I have some reduced fractions here. What is 27 over 6 reduced to? 9 over 2. A lot of the work that you're going to see on the SOL test requires some trial and error. You might have to test all of your answers in order to figure out situations like this. Similar. I got to think ratios. Everything's got to match up. Everything's got to be the same ratio. 6 and 10. 12 and 20. 15 and 25. Do those work out to the same thing? Are those all equivalent? You could go a decimal direction. You could say 0.6, 0.6, and I believe that's 0.6 also. You could reduce. You could say that's 3/5, 3/5, 3/5. It just turns out that the first one works. But you might have to go through the process of going through all four of them. If all of the ratios are the same, then you're okay, then it's proportional, then it's similar. Number 4 is just like problem number 1, only we're showing it with ratios instead of fractions. So I got two options here. Maybe these proportions are showing the pieces shortcut, in which case I'm dealing with just the little pieces of the sides. XL, LY, that's right there. XM, MZ, that's right there. So this problem is showing a proportion that is dealing with just the pieces. And if I separated the two like I did the other number 1, if I separated the two triangles and had XLM and XYZ, there aren't any other ratios in here that match up with those corresponding sides. Let's see, XM, XZ. XM is right here, XZ is right here, so that portion works. But then whoops, what did I do wrong here? Why isn't it J? Is that what I wanted? If I'm doing pieces shortcut? I would have wanted the XM there. Sorry about that. I got excited. So it's not a pieces shortcut. It is a corresponding sides problem. Let's see if I've got this right. XM goes with XZ. And does XL go with XY? Yes. Sorry about that. But keep in mind that it could be a pieces proportion at some point where you're just taking the parts of the sides and comparing them. Is there anything on the back of this? I have 10 here, 15 here, 20 here. What are we looking for? AE, we'll put an X there. This is a similar situation because of this. Because we have parallel lines, that means we have a lot of Z shapes and alternate interior angles in there. Because of AA similarity, it's similar, which means we can set up the proportion. Let's see. You got two choices here. I could possibly put the X, no, I don't have two choices here. Put arcs here and here. Because those are parallel, A goes with C. As a result, X corresponds to 20. This corresponds to this. It doesn't correspond to the 10. The 15 corresponds with the 10. Let's see. Those two are in the same triangle, those two are in the same triangle. That's how I set up things, triangle to triangle. 10x equals 300, x equals 30. Which drawing contains a pair of similar triangles? Let's see what the first one looks like. Is that equal? We've got vertical angles. If this is similar, then small has to go with small. It's not like the other one where we're cutting across. These aren't necessarily parallel. So this corresponds to this. Small to small, larger to larger. Both of those equal 1/2. That's what we're looking for. If you look back at the first page, there were 3 ways to prove that triangles are similar. Which one did we just use? SAS, similarity. The angle is the same and the sides are proportional. We have 2 right angles, and we're being told that 1 and 2 are reflecting off of a mirror, which makes them congruent. So this is an AA situation. These 2 angles are congruent to these 2 angles. As a result, I can set up a proportion. 12 corresponds to 264. What's the height of the guy? 5 feet high. And we are looking for the height of the building, which we'll call X. Let's see, is 5 more or less than half of 12? That's less than half of 12. So I would expect the answer to be less than half of this. Half of this is about 132. So I know the answer can't be that. This is probably too low. Is it 130 or is it 110? Is it 110? What was that? You getting heckled? I haven't seen that notation come up yet on an SOL test, but it could. If you see an arc with a slash through it, that's the same as us just using arcs to say that things are equal. What additional piece of information do I need? Well, I can't use AA because I only have 1 pair of angles. I can't use SSS similarity because I'm only allowed to put in 1 additional piece of information. So if I put a side there, I still don't know this side. And I need all 3 sides to do SSS. So the only thing this could possibly be is an SAS situation, which means that the angle has to be directly in between whatever it is we're doing. So I need this side so that I have something to compare to this 12. I got 12 and 8 that go together. If I do that, that is 144 divided by 18. That is 18. And the name of that side is NN. That's it. Anything left, or is that the last one?
That's it.
That's it.